This lesson creates a moving ball that bounces off all four edges of the window and recognizes the fact that the size of the window has changed and will adjust to fit the new size. The first commercial computer game consisted of a cursor that was bounced off blocks of color that you could move back and forth. The game was called Pong. This is the Pong One class. That's a frame that displays the window produced by a component class named Pong Canvas One. We're going to be moving things vertically and horizontally, so we need to do a few more declarations to be able to track everything. The Boolean variable moving right is true when the ball is moving from left to right, and it's false indicating the ball is moving right to left. In the same way, the Boolean variable moving down is true when the ball is moving toward the bottom of the window, and false when the ball is moving up toward the top. Whenever the ball reaches one of the edges, its direction can be reversed by simply toggling the Boolean switch on or off. Now, this rectangle object is created with the height and width being 0. This is just for convenience later on, so we can check to see whether this rectangle is the same size as the window. If it's not, and it won't be, we will create a new rectangle object that is of the correct size. This is all part of the magic we're going to do to have the animation become aware of any window size changes. There are dozens of other ways of doing this, but I like this one because I thought it up. The run method is basically the same as it was in the previous example. In fact, for animation, about the only change that ever occurs in the run method is that the length of the pause will change from time to time. We'll be doing that in the next lesson, but for now, it's still fixed at 33 milliseconds. It's here in the update method that most of the new stuff shows up. The first thing we do is check to see that the size of the actual window matches the size recorded by our internal rectangle object. The size of the actual component window is returned as a rectangle object from the getBounds method. The equals method of the rectangle class is used to compare the two rectangles. If they're not the same, and we know they won't be the same the first time through because we created a 0 by 0 rectangle to get started. If they're not the same, our internal rectangle is replaced by one that contains the actual window size. Now we're doing animation, so we'll need to do all of our drawing on a memory resident image, and we'll need a new one now, the new size of our rectangle. If the Boolean variable indicates that the motion is from left to right, then the value of x is incremented by 1. If the new position of x plus the diameter of the ball has reached beyond the right side of the window, then the variable moving right is set to false, so the direction will be reversed the next time execution comes through here, which will be the next frame. On the other hand, if the moving right Boolean variable was already set to false, this else statement will cause this statement to execute, moving the position of x 1 to the left. And if it does reach the left side of the window, moving right will be set to true to reverse the movement of the ball, so it will come back the other direction the next time through here. This code checks the Boolean variable moving down and adjusts the value of y accordingly. Just like with x, when the ball reaches either extreme, the Boolean value is toggled to reverse the direction. Finally, the paint method is called with a graphics object from the memory resident image, and the image is drawn on the window. The paint method is very simple, really. First, the entire window is filled with a cyan background color. After that, a blue ball with a black outline is drawn at the current XY position. And here it goes. It started out in the upper left-hand corner, which is point 0. Both x and y started increasing, which moved the ball down and to the right. Now this continues until the thing hits an edge, and then the direction is reversed. Whenever an edge is hit, only that direction is reversed, so the ball will continue on to hit the next wall, and one direction will be reversed again. But look at this. The window can be enlarged, and the program recognizes the change and adjusts its rectangle to fit it. If you reduce the size inside where the ball currently is, it will eventually find the rectangle and use the smaller window. Once it's inside, it will careen off the sides. Well, I guess in this case, careen is not exactly the right word. In the next lesson, we'll look at a couple of things we can do that will speed up the action.